Hello everyone, and welcome to Chapter 4, Compounds and Their Bonds. In the first section, 4.1, we're going to talk about the octet rule and ions. Atoms that are not noble gases form octets. Just like a duet is 2, a quartet is 4, an octet is 8. In order to become stable, atoms, when they form compounds, are going to lose, gain, or share the valence electrons, those electrons that are in the outermost shell, by forming ionic bonds or covalent bonds. Ionic bonds are when the atoms will transfer electrons, either lose or gain, and covalent bonds occur when nonmetals share electrons to attain what's called the noble gas configuration, and those are the atoms that already have 8 electrons in their valence shell. So an octet is 8 valence electrons. It's associated with the stability of the noble gases, except for helium, because helium's the smallest one. It doesn't need 8, it only needs 2 because it's so small it doesn't have 8. And so as you see, you have helium here with 2 valence electrons, but all the rest have 8 valence electrons, no matter how far out you go. Neon, argon, krypton you're seeing here. So those valence electrons are 8. And so the octet rule says that when other elements want to form compounds, they will either gain or lose to become ions that have the same configuration as those noble gases. And so the example here is the magnesium ion. And if you look at the magnesium ion here, it has 2 valence electrons. All right, so that means it has 12 electrons. If you look at the periodic table, that's where that's coming from. It's atomic number 12, so it has 12 protons, 12 electrons. Since it only has 2 in its outer shell, it will tend to lose 2 electrons and only have 10. When magnesium does that, it becomes it will have the same valence, that is 8 in that outermost shell, as the nearest noble gas, which will be neon. Chlorine, however, has 7 valence electrons. It's in group 7A. It has 17 protons total, 17 electrons total. And so its configuration is 2, 8, and 7. And so for it to have an octet, it really only needs 1. And so what will happen is the chlorine atom will gain 1 electron. That gives it an overall negative charge of -1 because it did have 17 protons and 17 electrons. Now it has 17 protons but 18 electrons. And so that's why it has that negative charge, because it has 1 more negative electron than it does positive protons. So metals form positive ions. If you recall, the metals, the metals are going to form, let me get my pen ready. Okay. The metals are going to have positive charges, and so if I get my pen over here right, I'm going to point out that you have +1, +2, if you remember this from class, +3. Okay, those are positively charged. That's what happens with our metals. And the metals are those ions that are basically along this jagged line here, okay? And that's how we can tell everything to the left of that is a metal, everything to the right of that is a nonmetal. And so what these do is they tend to, on this side of the chart, lose, because they've only got 1 or 2 in their outer shell, they tend to lose to become the configuration of this noble gas. And here they are over here. Okay, so this is going to make a little more sense here in a minute. But since they're in group 1, 2, they've lost an electron. They lose 1 electron, then they become a +1 charge. If they lose 2 electrons, like in group 2, they're going to be a positive 2. If they lose 3 electrons, they're going to be what? Positive 3, because now they've lost 3 of those negative charges, but they still have the positive charges. So when magnesium forms an ion, we said magnesium has 2 electrons in its valence shell. Okay, that's when it has 12 electrons and 12 protons. That's just the normal element magnesium. And so its electron configuration is 2, 8, and 2. And so it will lose those 2 electrons, and then it will only have 10. And so it has 12 pluses and 10 minuses. And so it formed what? A +2 ion as magnesium. So nonmetals, that is those guys that are over here to the right of that line, are going to form negative ions. And so that's where we get the -3, -2, -1 over here with groups 5A, 6A, 7A. And if you recall, those numbers tell you how many total valence there are. So you have 5 valence electrons, and so you gain 3, that equals 8. You have 6 valence electrons in 6A, and you gain 2. That gives you 8, and then in 7 you gain 1, and that gives you 8. But remember, since you're gaining those negative charges, it gives you what? A negative ion, or an anion, we call those guys, right? A-N-I-O-N, a negatively charged ion. And so in the case of chlorine, chlorine originally has 17 protons because it's atomic number 17, 17 electrons. So its configuration is 2, 8, and 7. And so in order to have an octet in this valence shell, we're going to have to add 1 electron because we already have 7. Okay, so we add 1. Then we only have 17 pluses. Now we have 18 minuses. And so that additional electron moves that 7 to an 8 and gives us 8 valence electrons now. So when you look at the group number over on the periodic table, remember this number right here tells us how many valence electrons. Okay, so I'm going to put a V there. Okay, and it will form a +1 charge. The 2A has 2 valence. It will form a +2. 3A will form a +3. And remember, everything in the same column will behave the same way. If you go over to 5A, it has 5. And I look at it kind of, okay, if it's more than 4, it is going to take electrons. If it's less than 4, it's going to give electrons. And so in 5A, you can form a -3, 6A a -2, and 7A a -1 because it gained 1, 2, or 3 electrons in order to satisfy the octet rule. So our first learning check here is write the formula and the symbol of an ion with 16 protons and 18 electrons. And that happens to be element S, okay? And if you recall, so I'm going to write S here because that's the symbol, and that's sulfur. All right, and so the formula for S, we know because it's in this particular row here, we know that it's going to be a -2, don't we? But why? Well, because it originally had 16 protons and 16 electrons to give it an overall neutral charge. Okay, but we know it's in 6A. All right, it has 6 valence electrons, so it needs how many to get 8? 8 minus 6 equals 2. All right, so it is going to what? Gain 2 electrons, which will now leave it with 16 protons and 18 electrons. Okay, and if I have 18 negatives and 16 positives. That gives me a -2, so that is S2 minus, and that's the formula for sulfide ion with 16 protons and 18 electrons, and so that is what we were looking for. So ionic charges we get from the group numbers. So remember, 1A, 2A, 3A, you get +1, +2, +3. Then you skip 4A, and if you remember why we do that, 4A has exactly 4, which is exactly 1/2 of 8. All right, and so 1/2 of 8, it really is the same whether you would give up or take away. And so that group, which contains carbon, they only share. They don't transfer or lose or gain electrons, and so those in that group only share electrons. So that's why we only look at 1, 2, 3, 5, 6, and 7. Remember also group 8A is what? Our noble gases, and so they're going to have a 0 charge already. So in this learning check, let's think about the elements calcium and chlorine. All right, and we're going to do several things with these two elements. First, we're going to identify each as a metal or a nonmetal. Then we're going to look and see if we can figure out the number of valence electrons for each. Then we're going to state the number of electrons that we must lose or gain in order to get an octet. And then finally, write the symbol with its charge and the name of the ion. Okay? So, first, what you need to do, and put it on hold and do this yourself, okay, is identify each as a metal or a nonmetal. And how do you do that? You look at your periodic table. If it's to the left of that zigzag line, it's going to be a metal. If it's to the right of that line, it's going to be a nonmetal. Okay, if you have looked at that, put me on hold for a minute, you saw that calcium is indeed on the left side of that, so calcium is a metal ion, and chlorine is to the right, so it is what? A nonmetal. Now, you can look at the group numbers to see what the charge is. Calcium is group 2A, and chlorine is group 7A, and so that tells us that calcium has 2 valence electrons and chlorine has what? 7 valence electrons. Very good. Part C of this was state the number of electrons that must be lost or gained for each to acquire an octet. We said calcium had 2, and so it has only 2 in its valence shell, so it will lose 2 electrons because it's less than 4. Chlorine had 7 electrons. It's not going to lose 7, is it? No. In order to have 8, it can just gain 1 electron, and it will achieve its octet, because 7 plus 1 is 8. And then why is 2 going to satisfy that? Because if you've got 2 in the valence and you get rid of 2, that leaves you with 0 in that shell, and so it defaults back to the shell before that, which should be full. So finally, we're going to lose 2 electrons with calcium, and so that's going to give us Ca what? 2 plus. And chloride, we gained 1, so that's going to give us Cl minus. Notice we don't have to do -1. 1 is usually understood in chemistry in most instances. Okay? All right. And that is the end of section 4.1. You can put me on hold, go get something to drink, maybe go on and do it later. But this is the end of 4.1, and then later come back and try 4.2.